Hey guys, thank you for clicking on this video. Today we're going to attempt the 2025. Let me just move this away. Here you go. You can see down here. The 2025 exam from Cambridge, the new Specimen paper, the non-calculator edition. So we're going to figure out how we can answer all of these within 2 hours without a calculator. Okay, so I'm going to put my head back down. Let's see. Okay, so these are a long list of formulas that you are given. It's quite a lot of formulas, and they gave you one for every shape. Great. Okay, and then the factorizing formula, you got your rules, sine rule, cosine rule. Okay, first question. Work out 0.01 squared. Okay, how do we do this? Well, I personally prefer to change it into a fraction first. So 1 over 100, and then we will square that. Okay, so what do we get? Squared just means two of that same thing. So 1 times 1, and on the bottom is 100 times 100. You don't have to write this. I just want to show you how it's done. So you have 1 over 10,000. Now, because there's 4 zeros, I can actually change it back to a decimal. The question didn't say that you must change it back to a decimal, but because the question gave you a decimal, I would normally return a decimal to the question. Yep. Okay, so 0.0001. How do I know that? It depends on the number of zeros. I can see that 10,000 has 4 zeros, so 4 zeros on the front. Okay, right. Next question. Correct to 4 significant figures. So we want 4 numbers. 1, 2, 3, 4. So you can see that I stopped at the 9. And then when we want to round up, we can see the number at the back is 5 and more. That's a 9. So we want plus 1. We'll have 57.40. Because when you add to the 9, it adds another 1 to the front. You get 40. Can you write 57.4? No, because that will be 3 significant figures. You must write 59.40. So sorry, no, 57.40. Okay, you must have that 0 there. Now, exchange rate question. Okay, €1 is $1.10. 250 euros, just times 250. So 250 times $1.10. I can see that there's a 0, at the 250, so I'm going to move it one decimal back. So then I'll have 25 times 11. This is a lot easier to work with. 5 times 1 is 5, 2 times 1 is 2. And then we'll put a 0, 25 to 275. You should get 275. Just write it in that space. Okay. Okay, triangle BCD is BDC is a straight line, ABAC angle 61. Okay, I can see everything is labeled. And I know this is one information. They said these two are the same length, right? So I can label another angle. This angle here is going to be 61 degrees. Okay, that's why it's very important to read the question. There may be some things that you'll have to label yourself. And you'll see that the answer almost always magically just pops up. Now, they want DAC. Where is that? DAC is up here, right? DAC. So that's the angle. They want this. And you can see that it is part of my triangle. And we know the total angle is 180 degrees. So I'll just have to minus the other two away. 81 and 61. I'm going to add them first because it's easier for me. 142. Okay, so 180 minus the total, it's going to be 38. Okay, so 38 is the answer. Degrees. Next question. Convert this to this. Okay. You should know that converting meters to centimeters, you times by 100. But because this is meters to centimeters, meter squared to centimeter squared, you'll have times 100 2 times. So 0.17 times 100 squared. Okay, squared comes from because the units are squared. Okay, I'm gonna write it out like the expanded version. 0.17 times 100 times 100. And you'll see why. It's because this 2 zeros will push my decimal backwards. And then I will have 17, which is a lot easier to work with, times 100. Or 17 times 100 is 1,700. And that is my final answer. Okay, next question. The mass of a solid metal cuboid is 4 kilograms. The volume of the cuboid. Okay, so they gave me mass, they gave me volume. Pretty sure we're going to be calculating density. I know that because I teach physics as well. Density, oh, perfect. They gave us the formula. So we can divide, right? Mass divide volume. But you have to be careful. We always look at the units. It says grams per cm cubed. They didn't give us grams. They gave us kilograms, 4 kilograms to be exact. So we'll take 4, we'll times 1,000. We'll get 4,000. And now that's when we can divide by the 600. Okay, so this is my mass, 4,000 divided by 600. I'll cut the 2 zeros, so that leaves me with 40 divided by 6. 40 divided by 6. 6 times 6 is 36. You have a 4 as your remainder. So it's 6, 4 over 6, which you can simplify into 6, 2 over 3. Yeah, that's right. Okay, next question. This is a vector question. What is minus? It says u minus 2v's. So I'm going to write down the u, which is 3, negative 2. These are not fractions. A lot of people will draw a line. Don't do that. Minus 2. V is the other one. So negative 12 and 5. Now you can see I haven't even done anything. I'm just putting in my u and my v in the right places. What now? I can multiply, right? Just like any other bracket. Bracket means times. So the u is untouched. I will have 3, negative 2 plus, okay, negative 2 times negative 12, that is positive 24. Negative 2 times 5, that is negative 10. And then this just, it works the same as your x and y. You can only add the 2 and the top together. You can only add the 2 on the bottom together. So 3 plus 24 is 27. Negative 2 and negative 10, that is negative 12. So we can just write that in. 27 and negative 12. And that is your answer. Pretty easy, still pretty simple, the first few questions. Find the magnitude of V. Okay, so this is, every time you see the 2 bars, that means you want to get the magnitude, you want to do Pythagoras theorem. I know what V is, it's negative 12 and 5. So negative 12 squared plus 5 squared, right? This is very similar to Pythagoras. Then you just put a square root over it. You should get 13. From my experience, it's 13, but I'll show you. 12 squared is 144. 25, 5 squared is 25. You get 169 from this, and then when you square root, you'll have 13. So there you go. And it's always positive, okay? It's always positive. 13. Okay, question 8. Diagram shows a semicircle with diameter 9 cm. Calculate the total perimeter of this semicircle. Okay, it's a semicircle. And then they want the total perimeter. Perimeter means you want this length, which they've already given you, the straight 9 cm. And then you also want this curved length. We actually call it an arc length. So you'll be doing the arc length formula. How do we get the arc length? Well, arc length is S, and then the total is 2 pi r. That should equal whatever they give you. So I can see that they didn't give me an area. That means I'm going to be using an angle. What is the angle here? It's half a circle, so 180 degrees. 180 over that total is 360. Oh, I'm going to do this in blue. 360. So that will be 1 over 2. The 2's can cut. So S equals pi times radius, which is half of 9. So what is that? Let's find out. Oh, they want it in the exact form. If you notice this word, exact form, that means you do not simplify the pi. You can leave it like that. So I will have 4.5 pi. Okay. And then perimeter, right? So we're going to have to add the other length that I talked about. P equals 9 plus 4.5 pi. And that should be the answer. Okay. Just going to duplicate that and put that in the answer space. Next question, in this sequence. Okay, 17 to 12 to 7 to 2. There's only a few choices that normally pop up. It's either plus minus. It's called arithmetic. There's a formula for that. There is times and divide. That is geometric. And then there's also the quadratic, the cubic sequences. That will be a separate thing. Okay, this one I can see the difference is minus 5. There is a common difference, right? Because 17 to 12 is minus 5. 12 to 7 is minus 5. So I'm pretty sure it's an arithmetic. They want the fifth term, right? They want T5. So what's the next number after 2? 2 minus 5 is negative 3. Okay, right. Tn. So every time they ask for Tn or the nth term, they will use these two words. So I'm going to write it in. Tn or nth term. Usually they like to use these two words. You want to get the formula. And because I know it's arithmetic, it's Tn equals a plus n minus 1 d. Now, a is the first term. So in this case, it's 17, right? Plus n minus 1. The d, the common difference, we found out it is minus 5, right? That's how you get the subsequent numbers. So minus 5. 17, we'll simplify it, plus, oh no, negative 5n plus 5. You'll have 22 minus 5n. And that is your answer. Okay. And then we'll just write this in that answer space over there. And then we can move on. All right, work out this in its simplest form. Normally questions like this, they don't want you to use the calculator. They want you to show you're working. Wait, no, it is paper 2, so no calculator. Okay. So how can we get this? We can times and plus, right? Times and plus, that's how we change it into an improper fraction. You'll have 3 times 2 is 6, plus 2 is 8 over 3. And we want to add it with 3 times 2 is 6, 7 over 2. Now, for every fraction, you got to make sure the denominator, the numbers on the bottom, are the same. So what can I do? I can continue multiplying. I'll use a different color. Let's times 3, because I know the LCM of 3 and 2 is 6. So I have 16 plus 7 times 3, the second fraction, is 21. I'm going to put them under the same denominator because they are. And then I can add them together. 16 plus 21 is 37 over 6. And then we can simplify this. Very, very easy. Just divide 37 by 6. 6 is 36, so you have 1 as the remainder. The remainder will always be part of that fraction. So you have 6, 1 over 6. And that is how you do question 10. Next, find a value of this. Okay, this is a very famous question. They love to give you a power, and the power is normally a fraction. I'd like to do the denominator on the power first, because that just means take it to the root of whatnot. So it's 64 cube root, because you see that 3 on the bottom? Yeah. And you do the cube root, and the 2, the power 2, the square did not disappear. You can see it's still there. I wrote it on the outside. Why do I do this first is because then my numbers become very small. You can't do this every time, but you can do this almost every time. Based on the questions I've done, normally you can take it to the third, fourth, fifth root. So when we cube root of 64, that is 4. 4 squared is, the squared is still there. I didn't do anything. So I'm just going to put a bracket just so you can see. 4 squared is 16. So answer is 16. Okay. Work out the following in standard form. Now, when it comes to standard form, you will love if it's times or divide because it's very straightforward. You can just do them separately. 7.1 times 2, let's do that first. That will be 2 and 14. So 14.2, that would be just the numbers. And then we'll also do the powers. So negative 15 times with 3. You know, when you multiply indices, the powers add up. So you'll have 14.2 times 10 to the power of negative 12. Negative 15 plus 3 is negative 12. But this is not standard form because standard form only allows one number. And then the rest could be a decimal. So you want, instead of 14.2, you want 1.42 times 10 to the power of negative 11. And that should be your answer. Okay, I will equal this. I will put this in the answer space. Okay, next. This is something you don't want to see, but you'll always see every time that it's a standard form question. It's always something multiplied on the top and then plus or minus on the bottom. Okay, so this works the same as algebra. You got to make sure they have the same times 10 to the power of whatever. Okay, one is 7 and one is 6. I will change that 7 back to a 6. So it would be 52 times 10 to the power of 6 plus 5.2 times 10 to the power of 6. Now you can see that they have the same, we can call algebra, like if they're an x, both of them are x now. Before that, one is an x, one is a y. Because they're the same, we can add them. It's just like 2x plus 3x. You know, you can add them now. When you add them, you will have 57.2 times 10 to the power of 6. Now the powers do not climb up. The powers only change when you multiply indices. In this case, you're adding the unknown, let's so-called unknown, is still there. It's still power 6. So of course, we cannot accept this. Standard form only allows one number. So it'll be 5.72. You can see I moved the decimal one step forward times 10 to the power of 7. And that is the answer. Okay, just gonna paste this into the answer space there. Question 13. Okay, find the number of sides of a regular polygon interior angle. And there's two ways of doing this question. Oh, there's two ways of doing this question. One is you can either use the interior angle formula. So that would be n minus 2 times 180 degrees. And then you divide by the number of sides. You should get 162. Okay, you can simplify all that. That is a lot of work. I personally prefer the exterior angle formula. So that would be number of sides equals 360 divided by your exterior angle formula. I prefer that. Why? Because I can easily get exterior from 162. So minus exterior angle. So I'm not gonna do that. I'm just gonna cancel this just so you can see I don't want that. Exterior is 180 minus 162. And this is universal. Whenever you add interior and exterior angles together, you get 180. So to get either one, just minus from that. You will have 20, you'll have 18. Yeah, you should have 18. Okay. Then we'll put the 18 in my formula. 360 divided by 18. Okay, let's do this on the side. $360 divided by 18. I think it's 20. Yeah, it's 36, 0, 0, 0, 0. It is 20. Okay, So you should get 20 sides. Of course, you can also get it using the interior angle formula. You can skip ahead if you don't want to watch this. You move the n to the other side. Right, I'm going to use a different color. You move the n to the other side. You should have n minus 2 times 180. There's many ways to simplify this. 162n degrees. Okay, now we can expand. You'll have 180 n degrees minus 360 degrees equals to 162 n degrees. Then you should have 18 n degrees equals 360 degrees. And then when you divide, you'll get the same thing, n equals 20. Okay, but you can see the numbers are way smaller if I did the other way. Okay, let's move on. The range, mode, and median of 5 positive integers are all equal to 10. Find one possible set of the, okay. 5 positive integers. I know 5 numbers, and they're gonna equal 10 for the mode, the range, the median. All right. Now, first off, of course, I would do 10, 10, 10, 10, 10. 10, 10, 10, 10, 10. Why? Because, well, I fit the mean, right? The mean is 10. I add all 5, I divide 5, I get 10. I also fit the median because the middle number is clearly 10. But you'll only see a problem when, the mode is also 10 because that's the one that showed up the most. The range is the problem. The range is the biggest number minus the smallest number. And if 10 minus 10, it's 0. You don't really get 10. So that means I'll have to reduce one number on the left corner, and then I'll have to raise the number on the right. So maybe I'll pass 5. So 5 and 15. Okay. So I still get my mode, median, mean. Range, yeah, I get 10. Okay, so this is it. This is the answer. It's 4 marks. So 5, 10, 10, 10, and 15. Okay. I have the mark scheme open, and they also accept these. They accept 4, 10, 10, 12, and 14. They also accept 6, 8, 10, 10, and 16. So there's more than one way to get it. This is just what I think is the easiest way, my thought process when I first see this question. Okay, 15. This is transformations. There's only 4 kinds, right? There's rotation. There is enlargement. Reflection, and translation. Okay. Now, translation involves moving something. If you look at A and T, nothing's moving, right? So no. Reflection involves seeing opposite things. And it's going to be very obvious as well. So no. Enlargement is even more obvious because things either get bigger or smaller. You can see it's not. So I'm left with rotation. Clearly, this is rotation. But how do you get your 3 marks in rotation? Rotation is always a 3-mark question. You'll have to mention the angle. So is it a 180 degree or a 90 degree rotation? This looks like 90 degrees for me. So I'm going to say 90 degree rotation. Okay. And then now you'll have to give me the second mark. Right. Is it clockwise or anti-clockwise? So we need to figure out which one is mapped onto which one. It says here T onto A. So we were at T and then we go to A. How does T become A? Does T go like that, or does T go like that? Because those are the only 2 ways you can move, right? Following a clock, the clock ticks down like that, tick, 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 tick. This is what we call clockwise. Okay, you can see that the T woke up to become A, like it stood up. And then this would be anti-clockwise against the clock. That would be A falling asleep, and then laying down you get T. So the other way would be anti-clockwise. In this case, it is clockwise. So I will say 90 degrees clockwise. And that's how you get your second mark. Actually, 90 degrees is your first mark, and then clockwise rotation no, sorry, rotation is your first mark, 90 degrees clockwise is your second mark. Now this is how you get your third mark. You have to tell me where it's rotating from. So for this, you can use that tracing paper. I've seen some people do. You can also use your eyes to try and pinpoint where it's rotating from. Okay. What I like to do is, because this is a relatively small picture, so it's quite easy to guess with our eyes and then just test one by one. But what if the picture is bigger? Normally, I like to use a tool that you can find in your geometric set. Okay, I don't have that tool with me right now, but if I had it, it's actually a triangle in your geometric set and it's transparent. Now, in every triangle, you know that corner there? Yeah, that is 90 degrees. So I could just put that and see where it maps into what I want. And then you can see it's done here, 4, 3, at 4, 3. Okay. How do I check? Well, it always has to be equidistant. So I'm going to take any corner, right? Let's say I start with this corner. I take one step here. We can see that this is a 90 degree to one step here. And I land on the same point. Right? If I take another point like this one, 1, 2 steps, right? Same 90 degrees. I go 1, 2 steps. I reach the same point on that triangle. Right? Okay, and then let's take this top corner here, right? 1, 2, 3. Okay. And then 90 degrees would be 1, 2, 3. And I land on the same point. Of course, it's easier if you just have that triangle thing in your geometric set. Okay, so that's how you get 3 marks. Rotation is 1, 90 degrees clockwise is the second, 4, 3 is your point of rotation. That's your third mark. Okay. Right, measuring the height of 400 plants. Cumulative frequency shows the results. Okay. So 400 plants, right? And then they want the median. So what is the middle of 400 plants? 200, right? That's the middle. So I will mark it on my graph, 200. And I'll drag that down. You can see that I landed at 30, right? So that's the median, 30, middle. They want the interquartile range, which we have a formula for. Quartile 3 minus quartile 1. Quartile is just another way of saying quarter. So 1 over 4 and 3 over 4. That's what you want. 1 over 4 of 400 data is 100. So 100, where are we? 100 is in the middle of these two. And then you can see I can drag down. Okay, that looks like 12, 14, 16, 17. That looks like 17. Oh yeah, okay, yeah, 17. Let's, because we have to minus, right? So quartile 1 is 17, and then we'll get quartile 3 now, which is 400, 304 is 300. So 300 is here. And then I will drag down. Okay, so nicely drawn. That would be 32, 4, 6, 7, 37. Okay, 37 minus 17, that would give me the 20. That is correct. Okay, they want the 80th percentile. So 80th, 80 over 100 times 400. So they want 320. Number 320, where is it? Okay, there we go, 320. And then we'll just drag it down. Okay, nicely there. I will have 39. Yeah, so it's 39. Okay, 39. Okay, so this works for everything. Like 80th percentile, so get 80% of all your data. In this case, it's 320. Interquartile range, you want to get quartile 1, it's 1 over 4 of all your data. Quartile 3, it's 3 over 4 of all your data. Okay, So another way they can ask is they want the 25th percentile. That is also the first quartile because 25th percentile is 25%, which is the same as 1 over 4. And then 75th percentile is also quartile 3 because that's 3 over 4. Number of plants which with height greater than 60 cm. Okay, so 60 cm is here. Let's mark it. Okay, you can see I marked 60 cm here. And let's find out. Okay, so that looks to me like if this is 380, so lazy to calculate the boxes. Okay, whenever it's like that, and as you age, your eyes aren't very good. I know there's 5 boxes in that one small column, right? So 5 boxes equals, and then I know the gap is 40 numbers because 360 to 400 is 40 numbers. So 1 box equals 8. And you can see I'm at half a box. So 4, right? Half a box, 1 over 2b equals 4. So that would be plus 4, 364. So I would say it's 364 where I want. And then what do they want? They want height greater than 60 cm. So anything above 364, we want. I can minus 400 minus 364, right? 400 minus 364. You know what? I'll do it on the side. So that will be 6. 46. No. 36. Okay. So based on what I drew, they accept. I got 36. But the mark scheme says they accept anywhere between 34 to 38. So maybe because I'm doing this on an iPad, it straightens itself. It's very easy to draw a line. But maybe if you're doing it in real life, sometimes human errors, you're going to be 1, 2 numbers off, 1, 2 decimals off. So you're not going to really get 36. You're going to get between 34 and 38. And I got a really nice number because 36 is in the middle of what they accept. Okay. Right. B. This is a frequency table. Now, normally when it's group data, how do we get the mean? We directly multiply, but you can see that they didn't give us one perfect pretty number, right? They give us a range. Okay, but that's not a mean question. Complete the histogram to show this information. This is frequency density. How do we get frequency density? We take frequency and we want to know how dense it is, so divide by height. So in this case, frequency density, I'm going to use FD. When I divide the first one, 120 by 20, it's 6. Okay, so that's how tall I want to draw my histogram, 6. And then when I look at my example, oh, perfect, it's at 6. I don't need to ratio anything out. Okay, and then the second one, this is 10, so 8. I want to draw 8 on the second one. 124 to 10, so 12.4. Okay, again, there's 10 numbers here. There is 10 numbers here, so just divide. And then there's 40 numbers here. This one I'll have to do on the side. 76 divided by 40, 140, 360. 0.9, right? So I'll get 360. Okay, so I want to do 1.9 on the last one. Right, so let's start drawing. 8 is here. Wait, no, they want us to draw until 30. So you also have to be careful about where to stop. So in this case, they want 10 to 30. I will do that. I will redraw. Okay, and then the next block, I want to draw 12.4. And I stop at 40. So 40 until 12.4. Okay, so 13 is here, right? That means 12.4 is going to be the first box. Okay, or you can use that same thing that I did previously. So 12.4 is on the first box. I stop at 40. And there you go. Stop at 40, and that's 12.4. The last one, 40 till 80, and I want to do 1.9. So all the way till the end, and I want 1.9. 1.9. Okay. So I know 1 is here because it's in the middle, right? 0 to 2, so in the middle should be 1. And then 0.9, 2, 6. Okay, so almost all the way at the top. Okay, so this should be your histogram. Let me check. Yeah, those are the correct ones. Make sure you also draw according to the correct width, so all of them will have a different shape. Okay, done. Question 17. Okay, this is a cyclic quadrilateral. So first rule of that is opposites add up to 180. And I can easily see my first thing now. 74, so the opposite would be, let's see, 6. 106. So here is 106. That means just here is 106 minus 34. Let's find out. 6 times 4 is 2. Sorry, minus 4 is 2. And 7. Okay, so this is 72. Okay. Now, I haven't even started the question. This is just based on the word cyclic quadrilateral. I know that opposites add up to 180. So I want to figure out what each point is. Okay, and then they intersect at x. Okay, perfect. That means opposite angles are the same. And then BAD 74, BCA 34, they've labeled both of these in, which is good. Thank you, Mr. Question. Angle BDA. Okay, BDA. BDA. So they want this angle here. All right, okay, so they want that angle up there. How can we get that? Okay, there's something, well, at least what I call it and what my teachers used to teach me is there's something called a butterfly. This is what we call a butterfly, right? And the ones that are pointing in the same direction are the same angle. So these two that I labeled up here are 34. That means my BDA is 34. That's what the question is. Okay. So BDA is 34 degrees. And then they want BCD. Where is that? BCD. Okay. BCD. Oh, that's what we have, right? We have 106, and we also have the working for it. So that is 106. ABD now. Okay. ABD. So they want this one down here. How do we get this one down here? Well, I see a triangle. This, and this, right? And we know that angles in triangle add up to 180. So I just have to minus 34 and 74. That's what I'll get. 34 and 74. Okay, 34 and 74. That's minus. Six, 7, 4. 146. And then I'll minus 2, 7. So the answer is 72. Okay. Right, we have it. That's it. And it's very important to label everything based on the information you have. In the diagram, triangle ADX is similar to BCX. Okay, ADX is ADX. Oh, okay. I'm actually going to copy this page and paste it on the next one. Okay, so we want ADX. ADX. And then it is similar to BCX. Okay, so BCX. Yeah, they are. Okay. That means they'll grow and shrink at the same scale. Okay. And then they gave us some lengths. I'm going to erase all the angles now because they are no longer needed. And we will label the lengths in. Okay. BC is 4.5. BC is 4.5. I'm going to also erase these on the side. AD is 9. CX is 3.3. AD is 9. CX is 3.3. Okay. And all of these are in cm. Work out XD. XD. Okay, so XD is basically the same as CX. So let's do that. The scale. The two sides that are the same are 4.5 and 9. So we know the scale is times 2, right? And if we want XD, which corresponds to this side, the 3.3, we can just times 2. Same thing. We can just times 2. So the K is 9 over 4.5. I will always take bigger divided by smaller. That's 2. I know the scale is 2. And then I want the other length, xd, which is just 2 of the 3.3. Answer is 6.6. Okay, just double of that. All right. Oh, okay. Looks like I inverted pages. I'll rearrange that later. Okay, 18. Functions. I don't know why a lot of people don't like this ever since it's been introduced. F3, okay. I'm going to write down fx just so you can see how to actually think about this. Fx equals 3 minus 2x. All right, that is from the question. So if they want x, f negative 3, the only thing I'm changing is the x inside with the negative 3. So that also makes sense if I change the outside with a negative 3. Okay, I'm going to use a different color just so you can see. Now, hopefully this clears things out. And of course, you can just simplify this. That will be 3 plus 6, so that's 9. Okay. GF negative 3. Okay, so they are reusing the F negative 3 that I found. So GF negative 3 is basically the same as, what did we get from the F negative 3? 9. So it's the same as G9. Okay, I put in that negative 3 with a 9. Okay, because that's what I got from A. G9, that's what they want. I know what GX is, right? So I'll move this down a bit. GX equals 2x plus 3. 2x plus 3. And now, same thing. The only difference is they swapped out the x with a 9. So I'm going to also do that. 2 bracket bracket plus 3. And then my x is changed to a 9. So I will have 18 plus 3. The final answer is 21. That is how you do functions. Now this inverse, we always say let y. So y equals fx. That's what you want to do. Yeah, so fx is 3 minus 2x. 3 minus 2x. Okay, we always let y. So I'm just going to write down top. Let y equals fx. But has anyone ever told you why we do this? It's because when we swap, when we get the inverse, we have f inverse of y, and that equals x. And then we can anytime just change it back, and you'll have the inverse function. But I'm not going to talk about that unless you want to know more. Just leave it down in the comments. So let y, we're going to rearrange it. Y equals that, and then y minus 3 equals negative 2x. X equals 3 minus y over 2. Okay, so hopefully you're good at algebra to simplify this. X equals this, but I also know, remember from the explanation I gave, x equals to f inverse of y. So I'll sub it in. F inverse of y equals 3 minus y over 2. And remember the function rule that I told you, what's inside is also on the outside. So you see this y here and the y here, right? I could just swap that with an x. So F inverse of x here should equal 3 minus x over 2. And that is my answer, which solves the question up here, finding F inverse of x. Okay, so 3 minus x over 2. Find x when gx equals 7. Okay, so let's write down gx and see what that is. Gx is 2x plus 3. Okay, and then what gx? So g, no, what's on the inside is gx. And remember that what's on the inside is also what's on the outside. So I have 3 gx plus 3. No, sorry, 2 3x plus 3. And you can see even until question 4, question C, they're still following the same rules that I teach. So we can sub in what gx is. We should know what that is, right? Gx equals, what is gx? Let's sub in 2x plus 3. So 2x plus 3 and then plus 3. Okay, we can expand it. You'll have 4x plus 6 plus 3. So that is 4x plus 9. That is gx. But we don't stop there. Make sure you read the question. It says they want gx, which is what we already have, equals to 7. So they want this thing, and we want it equals 7. Okay? And you can see that we can continue, and eventually we'll get our x. Everything magically just pops out. So 4x equals negative 2. That means x equals negative half. Okay? Negative half. All right. Next question. Find x when inverse of h equals 5. Okay, so we'll do inverse of h. Inverse of h. H is 2 power x. hx equals 2 power x. Hx equals 2 power x. Now, normally in maths, if you take that subject, we will just inverse this. You'll get a logarithm. You wouldn't know what that is if you just take normal math. And then we'll just equal 5. But in normal math, you don't learn about that. So what we're going to do instead is, instead of inversing the hx, we will inverse the inverse. So h5 equals x. That is what you want to do. h5, okay. So this is the key information that I will play with. I have hx. Now they want h5. So just going to change, just so you can see. h5 equals 2 raised to the power of 5. And that is 32, yeah. So I know what h5 is. It's 32, right? And from what I understood, h5 is also equal to x. So if h5 is 32, h5 is x, then they should equal, right? X should equal 32. That is your answer. 32. Okay. If you're struggling with understanding that, that means you don't have very strong basics in algebra and you will need tutoring help. Okay, simplify this. How do we simplify? We have to take the square root of the possible numbers that you can get. So 32, what are multiples that you can square root? We have 8 times 4, that's 32, but you can't square root any of that. You also have 2 times 16. So 16 we can square root, right? 2 times 16 plus 98. I think I can divide by 7. Let's try. 14. 7 and 14, none of which you can square root. Maybe 4? No, 2. Okay, so one tip when the number gets too big is, I almost forgot this. I know I can square root the 16 from the first one. That means I'm going to be left with 2. So I'm definitely also going to be left with 2 on the other one. That's how I can plus them together. So that's my trick that I almost forgot. 4, 8, 18, 9, 48. Yeah, there you go. No, sorry, 49. And then you can see no remainders. So 49 we can square root, that's a 7. So 2 times 49, square root of 16 is 4, right? So 4 cert 2 plus 49 7. So 7 cert 2. You see what I mean by they will both have a cert 2 at the end? So I can just divide by 2 and figure out what the other number is. In my experience, it always works for IG. Unless you're taking SPM, then they like to play tricks on you. Okay, 7 plus 4, that's 11. So the answer is 11 square root of 2. Okay, that is what you will have. Now, next question. Rationalize the denominator. Rationalizing, there's 2 kinds of fractions. One is just this. So when it comes to this case, you just want to times the same thing, top and bottom. Okay, so this is what you want to times. And the second case is like this, like in this question that we're looking at, there's an operation in between. There's a plus or there's a minus. So we'll multiply by the opposite, which is square root 2 minus 1. They use plus 1, we're going to use minus 1 on both top and bottom. Okay, so we can multiply on top. We already know what it is because when you times 1, you get that. And then when you simplify the bottom, I already know this, you just have to multiply the front and the back. There's no middle because they'll cancel out. That's why we call it rationalized. So that's 2 minus 1. So answer is square root 2 minus 1. When you simplify the denominator, you get 1. So it disappears. Okay, now that we're done, next question. Oh, let me just put it in the answer space. Okay, this is a proportion question. So we have to change it to equals, and then you'll have k on top. That's y equals k over square root of x. Okay, and then the first information is y is 8, x is 4. We can sub that in very nicely. 8 equals k over square root of 4, which is 2. So k equals 16. Okay, good. I know what k is now. I will reuse that with k to get y, because if you notice the next part, it's find y when x equals 49. So y equals, k is 16 now, I know that. And then the x is 49, so I'll square it by 49, which gets me 7. 16 over 7. We can change this to a proper fraction by dividing. 14, left with 2. So remainder is 2. 2 over 7. Okay, so that's what you want to give. Next. Okay, question 21. All right, so they gave us some random information. They told us everything is in algebra. Not very nice. And then they also said the area of the triangle is 11 cm squared. Okay, we can actually do something with that. Area is 1 over 2. Base height is x and h. And it equals to 11. This is what they said. Area of the rectangle is 39. So we can also get that, right? We can get area of rectangle, which is h plus 2. This is the base height. So x plus 1, h plus 2, and that should equal 39. Okay, so we've gotten these two. What do they want? Write down the expression for the height of the rectangle. Okay, well, the height is h plus 2. Right? I can see it. That's the rectangle. The height is h plus 2. So we can rearrange this. H plus 2 equals 39 over x plus 1. So that will be the height. Okay, I mean, this area of triangle thing, I'm pretty sure I'll be using it in the next question. Okay, now show this equation. Okay, so quadratic, normally it's simultaneous. You combine them, then you'll get a quadratic. So I already have h plus 2. I could sub in there. So I'll rearrange this. H equals 22 over x. And then I know h plus 2 is this. I'll bring that over here. Right. I can sub the h from the triangle into that rectangle height formula. So I will have 22 over x plus 2 equals 39 over x plus 1. I can make them into a single fraction on both sides. This 2 is basically over 1, so times x. I will have 22 plus 2x over x, and then minus, as I know, equals 39 over x plus 1. Okay, so I'll just cross multiply that. You'll have 22x plus 22 plus 2x squared plus 2x. This is all on the left side when I cross multiply like that. Okay, and you should get equals 39x. So we can simplify this. 2x squared, which is the same as what we have on top. That's very reassuring. And then we should have negative 15x. Let's see. 22, 39, yep, that should be negative 15x. And we also should have 22. Let's see. Yeah, we do have a 22 standing right here, right? So I'll just plus 22 and now equals 0. And you can see we showed what they wanted. I'm just going to write shown just so the examiner knows where to look at. Okay, and this is expected. They want you to factorize that, find the two possible heights of the triangle. Now, there's something called a box method, which is a lot faster. If you don't know that, it's okay. You can always go back to the quadratic formula, which is your negative b plus minus square root. Yeah, all that. So I'm going to use the box method that I know. 2x squared, 2x and x, 22. So that's 11 and 2. 11x and 4x when I cross. That would give me 15x. Okay, but the 15 in the question is negative. So if this is negative, that means my 4 and 11x will be negative. That means they must come from these two. And then the final result is this and this. So I can just write that out. That will be 2x minus 11 and x minus 2. Okay. Equals 0. So 2x minus 11 equals 0, or x minus 2 equals 0, x equals to 2, x equals to 11 over 2. Okay, so those are my two x's. That's not the final answer because they want h, right? So we'll just sub it in the h formula, which we have nicely here waiting for us, 22 over x. So h equals 22 over, your x is 11 over 2. You should have 11. Yeah, 11. And then h equals 22 over 2. 11. Wait. 2. No, sorry, this should be 4. Yeah, 4. Okay, so 4 and 11. 4 and 11. That is how you get 5 marks. Okay, if you don't know this, it's really still completely okay to do the quadratic formula. negative b, our b is negative 15, plus minus square root of b squared, so it's still negative 15 squared minus 4, a is 2, c is 22, okay? All this over 2a, which is 2 times 2. And you'll still get your 11 over 2 and 2 if you simplify that slowly, okay? All right, question 22. All right, question 22, we're almost there. Find the exact value of x. I have an angle, I have a length, so SOHCAHTOA, if you haven't heard of that. 30, the opposite of 30 is here, so I'm going to just label that as opposite. 8 is not the longest length, so that would be my adjacent. And then x would be my hypotenuse because that is the longest length. So I have adjacent and hypotenuse, then that would be cosine, right? So cosine of x equals, no, I have the angle. Cosine 30 equals a and h, so 8 over x. Okay. So we can draw a line, and then we will draw the triangle. Okay. So 30 is here, that would be 1. 60 is here, 2 will be here. Then we can get this length here, which is just 4 minus 1, square root of 3. Okay, you can memorize this triangle. Normally, you're supposed to memorize 2 sides, so you can Pythagoras to get the third one. I like to memorize this. So how do we do it? We can get cosine from here. We'll know what cosine 30 is. Cosine 30, cosine 30 will be adjacent, which is surd 3, over hypotenuse, which is 2. So I know what cosine 30 is based on this. And then I can sub it back to my original question on the left. So that would be 8 divided by surd 3 over 2. Okay. Then we'll flip it. We'll have 16 over surd 3. And remember the second kind of rationalization I told you about? So we can times surd 3 on top and bottom. Okay, so rationalization times surd 3 over surd 3. You will have 16 surd 3 over 3. Okay, and that is what you want to write. You must rationalize, like that is non-negotiable. Okay, but you know what? The mark scheme actually allows you to not rationalize. But normally, if you're doing admins, you're supposed to. Okay, so maybe my habit came from there. All right, so the marks, they could also award you back when you had this. Okay, or this. It's better if you rationalize, especially if you're an admin student. It's just extra practice, and it's not a lot of work really. Write a single fraction. Okay, so we want this as a single fraction. We can cross multiply to equal the denominators. So then that will be 3x plus 3 minus 4x minus 4 all over. I normally don't expand the bottom because you don't need to. So x minus 4, x plus 3. Okay, in case you don't know what I just did, I did the same thing, cross multiply. Okay, now the difference between this and the previous question that I did cross multiply with is there is no equal sign. So you'll still have the fraction and you'll have to accept it, deal with it no matter what. Right, so we can expand this. 3x plus 9 minus 4x plus 16 all over x minus 4, x plus 3. Okay, you'll have negative x plus 25, yeah, all over x minus 4, x plus 3. So I'm going to rearrange it. Instead of negative x plus 25, I'm going to write 25 minus x. you'll still get it right, even if you write negative x plus 25. I just prefer to look at it this way. It looks prettier. Okay, do you need to expand the bottom, the denominator? No, you don't need to. And it's also good to just leave it like that because you never know when you can simplify with the numerator on top. You might, some questions they allow you to cancel, so I'm not even going to touch that. So we can just paste this into the answer space. And voila, we're done. Okay, write this in the form of that. So this means completing the squared. Okay, completing the squared. So x minus b over 2 bracket squared minus negative, which is your b. So b over 2 squared plus c. I have that in my head. So what do we have? 4 over 2 is 2. So x minus 2 squared minus 4 plus 7. So x minus 2 squared plus 3. Yeah. Okay, so we'll just put this in the answer space. Done. Write down the coordinates of the turning point. Okay. Turning point means dy dx. So dy dx. dy dx. Okay, there are a lot of other keywords that I teach my students in my class. Turning point is just one of them. You'll also see minimum, maximum, and stationary point. Every time you see these words, dy dx equals 0. Keyword is dy dx equals 0, okay? And you'll see why. So when you do dy dx, you'll have 2x minus 4. Okay, and remember what I told you, dy dx equals 0. I have dy dx equals 0 means x will equal 2. Now that I have x equals 2, guess what? You'll have to get the y because they want coordinates. If that wasn't obvious enough, look at the answer space. It's a coordinate. So we can sub it back in. Y equals 2 squared minus 4 times 2 plus 7. It's 2. I'm putting in that in first. 4 minus 8 plus 7. So that's 3, right? Okay, 3. And then that's how you do this. This is a 1-mark question. Pretty straightforward. Okay. 25. Okay, the keyword for this kind of question is the same thing. Similar, right? Similar. So they will scale up and down the same way. Very important word. I normally get the scale factor, but you can also do ratio on this. Area of the larger shape and smaller shape. Okay. First, let's figure out the ratio. Smaller is x. Larger is 9. Okay, I'm going to smaller, larger, x and 9. Okay. And then they gave me area, 36 and 25. So 25, 36. Now, you have to be careful because they gave you area and they want you to find a length. So you have to change the area back to a length. How do you do that? Square root. Okay, you have to do a square root on both of these. That way, they have the same units, and then you can use the ratio method. So you'll have 5 against 6, x against 9. You can do your ratio, right? You'll have 6x equals 45. X will equal 45 divided by 6. 8, 7, 42, 3. So 7.5, right? 7.5. 7.5. Okay, we got it. That is it. 26. Okay, it's the last question. Very nice. They gave us a formula, x plus 2, x minus 3. So I'm able to get my 3x's, right? Just equals 0. You'll get it. Equals 0. Then you'll have x equals 0, negative 2, and 3. Okay, let's label that in. 0, negative 2 is here. And 3 should be here. On the diagram, sketch the graph for this, show the values of intersections. Okay, so we have to look at the x. If you combine the x's, this, and this, it's going to be a positive x cubed. So it's going to go up in the end. So let's draw up, down, up. Yeah, maybe it could look prettier. Give me a sec. Okay, let's just accept that it's very hard to draw digitally. Position eraser. You want to make sure you stop at 4 and 3. So you can see I'm not there yet. Okay, that way I follow the range of -3 till 4. And yeah, and then they also want you to show the intersections. You can see are intersected with a 0 there. So that's it. That's the only intersection. There's no other y-intercepts other than this one. Okay. Expand and simplify. All right. Very simple. This is x squared plus 2x. And then x minus 3. And then you can keep multiplying. You'll have x cubed minus 3x squared plus 2x squared minus 6x. So it is x cubed minus x squared minus 6x. Okay, is that it? Yep, that is it. A is, oh, let's put it in the answer space. A is a point, 1, -6, okay? Tangent of the graph is that, okay, A is a point this. Tangent to the graph means the y-axis. Okay, so we want to get tangent. And in every curve, tangent is dy dx. Okay, so dy dx equals, oh, we expanded it up there, right? So we'll have 3x squared minus, we'll have 3x squared minus 2x minus 6. Okay, and then we want to, this is the gradient, by the way. Okay, and then we're given a point. So at 1, 6, your dy dx will be 3, 1 squared minus 2, 1, -6. And you'll have 3 minus 2 minus 6, which is negative -5. Yeah, m. Okay, so every time you do dy dx, you'll actually have the gradient function, which basically means you have a formula for the gradient. What could the gradient be? Because it must be a number. That's when you sub your x in, and you'll have a number out of that. Okay, so I have a gradient, and I can now get my tangent line. Tangent is always a straight line. So y equals mx plus c, right? Y equals mx plus c, sub it in. There's a very nice formula as well, but I'm not going to teach that here because we're trying to go no memory. So I don't have to memorize that really long formula. I will just do y equals mx plus c. I know what the y and the x are. It's -6 and 1. So -6, m is -5, 1 plus c. C equals -1. So y equals -5x minus 1. So that is my tangent equation. And this tangent at A meets the y-axis at B. So I have this tangent line, and it says they're meeting the y-axis. Y-axis means x equals 0. So let's put that in. Y equals -5 times 0 minus 1. So you get -1. So the coordinates is, well, I already subbed in the x equals 0, right? That's the x. And then the y is -1. 0 minus 1. 5 marks. Okay, and just like that, we are done with the paper. Okay, even for this last one, a lot of people struggle with this because it's 5 marks, it's dydx, people are unfamiliar, people are scared. You don't have to be, just follow the steps. Okay, so step one, they said tangent, so I'm gonna dydx, because that will give me the gradient, and then I can get my straight line, y equals mx plus c. And the second step, they said y-axis, so x equals 0. When I sub it in, you can see I got the coordinate, and there's not a lot of thinking needed if you follow my methods. Yeah, you just have to know the keywords and know what to do when you see them. All right, thank you for watching, and hopefully you are eager to watch the next video.